Welcome to the session on algebraic methods, algebraic division. The objectives for this session are to divide a polynomial by a linear expression. An improper algebraic fraction is a fraction whose numerator has a degree greater than or equal to the denominator. Before expressing it in partial fractions, we must convert it to a mixed fraction. Let's take a look at some examples of improper fractions. X cubed minus 3x plus 8 all over x minus 2 has a numerator with degree equal to 3 and a denominator whose degree is equal to 1. The degree of the numerator is greater than the degree of the denominator. Another example of an improper fraction is x cubed plus 4x minus 8 all over x cubed minus 4x squared plus 6x minus 2. Here, the degree of the numerator is 3 and the degree of the denominator is also 3. The degrees of the numerator and the denominator are equal. How do we convert an improper fraction into a mixed fraction? The first method we will look at is algebraic division. Here we use algebraic long division to show, for example, that x cubed minus 3x plus 8 all over x minus 2 is identical to x squared plus 2x plus 1 plus 10 over x minus 2. Here's our function. Here's what we refer to as q of x, the quotient. 10 in this example is the remainder, and x minus 2 is the divisor. The other method we could use to convert an improper fraction into a mixed fraction is using f of x equals q of x times the divisor plus the remainder. Here, we would multiply by x minus 2 and compare the coefficients in order to show the formula that you can see, or the identity that you can see on your screen now. Here's f of x, here's the quotient q of x, here's the divisor, and here's the remainder. We will now have a go at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a first. We are required to divide 3x cubed plus x squared minus 2x plus 5 by x minus 1. Notice that a polynomial is a finite expression with positive whole number indices. It is possible to use long division to divide a polynomial by x plus or minus a constant c. So let's solve example 1a. Set out the problem as shown. Again, begin by dividing the first term of the polynomial by x, so that 3x cubed divided by x equals 3x squared. And position the 3x squared here. Next, multiply this by x minus 1. To give 3x cubed minus 3x squared. Next, subtract to give 4x squared as shown, and bring the minus 2x down and position it here. Then repeat the method. Divide 4x squared by x to give 4x. Position the 4x here and then multiply by x minus 1. To give 4x squared minus 4x. Subtract to give 2x and bring the 5 down and position it here. Now repeat the method. Divide 2x by x to give 2 and position it here, and then multiply by x minus 1. To give 2x minus 2. And now subtract. To give 7, and so we have a remainder 7. This means that we cannot write this expression in the form x minus 1 times by a quadratic. Let's now take a look at example 1b. Given that 3x cubed plus x squared minus 2x plus 5 is identical to ax squared plus bx plus c times x minus 1 plus d, find a, b, c, and d. You will probably notice that the function and the divisor are the same as those in part A. However, we're going to use a different method in order to find these constants. So let's solve this. We're going to begin by letting x equal 1. You may be wondering why we've chosen this particular value. If we look at this expression, notice what happens when we put x equal to 1 here, highlighted in the red box. Clearly, this bit is going to equal 0, and then we're going to find a nice neat expression for d. So let's plug in x equal to 1. We have on the left-hand side 3 plus 1 minus 2 plus 5, if we plug in x equal to 1. And on the right-hand side, we have a plus b plus c times 0, which was our intention. And of course, plus d, which we're trying to find. So rearranging this gives us that d is equal to 7. Now we let x equal 0 in order to help us find one of the other constants. So let's plug this in. On the left-hand side, when we plug in x equal to 0, we have 5. On the right-hand side, we have 0 plus 0 plus c times minus 1 plus 7, because we know that d equals 7. And rearranging this gives us that c equals 2. Now let's equate the coefficients of x cubed. On the left-hand side, the coefficient of x cubed is 3. On the right-hand side, the coefficient of x cubed is going to be a, because there is only one way of obtaining ax cubed, or x cubed, when we multiply out the brackets. if we equate the coefficients of x squared, then on the left-hand side we have 1x squared, so the coefficient of x squared is just 1 on the left-hand side. And on the right-hand side, we can obtain x squared by multiplying ax squared by minus 1, or by multiplying bx by x. So the coefficient of x squared on the right-hand side is minus a plus b. And plugging in a equals 3 gives us that b equals 4. So here are our constants. We have a equals 3, b equals 4, c equals 2, and d equals 7. Therefore, plugging these all in gives us 3x squared plus 4x plus 2 times x minus 1 plus 7. We can re-express this as shown. Here we've simply divided by x minus 1. And now for example 2. Pause the video and have a go. Press play when you're ready to view the solutions. We are required to show that the function given on the screen can be written as ax squared plus bx plus c plus dx plus e all over x squared plus x minus 4. And we're required to find the values of a, b, c, d, and e. So let's solve this. We're going to write our equation out as shown, in the long division format as we did previously. So we have our polynomial divided by x squared plus x minus 4 on the outside of the divisor sign. Now x to the 4 divided by x squared is x squared. So position x to the power 2 here. So if we multiply x squared by the divisor, we obtain x to the 4 minus x cubed minus 4x squared, and we position that as shown on your screen. Next we subtract, as shown, to obtain 3x cubed plus 4x squared, and bring the plus 3x down as shown. Now 3x cubed divided by x squared is 3x. So we position 3x here as shown. 3x multiplied by the divisor gives us 3x cubed plus 3x squared minus 12x as shown. We now subtract to give x squared plus 13x, and then bring down the minus 5 as shown. X squared divided by x squared is 1, and we position that here. And so we have 1 times x squared plus x minus 4 is x squared plus x minus 4. And then subtracting as shown gives us 14x. minus 1. And therefore, we can re-express our polynomial divided by our divisor as x squared plus 3x plus 1 plus 14x minus 1 all over x squared plus x minus 4. Here's our polynomial, here's our divisor, here's our quotient, and here's our remainder. So if we answer the question we were originally asked, in other words, find the values of a, b, c, d, and e, we have that a equals 1, b equals 3, c equals 1, d equals 14, and e equals minus 1. This brings us to the end of this session. If you have understood its contents, you should be able to divide a polynomial by a linear expression. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to it.